Students, today we start ex2.4 chain rule. The composition f of g of function f and g is the function whose values f g of x are found for each x in the domain of g, and for g of x is in the domain of f of g of x. Theorem: if g is differentiable at the point x and f is differentiable at the point g of x, the composition function is differentiable at the point x. Now we can write this. The proof of the chain rule is beyond the scope of this book. Now we have y is equal to f of g of x. We can write it as f g of x. Then its differentiate is f of g of dash of x and f of g of x, and then dy by dx is equal to f dash of g of x, and then derivative of the inner function. Now we let u g of x and y becomes f of u, because we let g of x is equal to y. U is equal to g of x. Now differentiate with respect to u, so it becomes du by dx, and derivative of g of x is g dash of x, and derivative of y is become dy over du. It becomes f dash of u. Thus one can be written in the following forms: d by d of x, f of u, we put the value of y, and then derivative of f dash of u, and then derivative of the base du by dx. So it becomes dy over dx is equal to dy by du, which is equal to f dash of u and du by dx. Let we have a function y is g of x raised to power n. We let u is equal to g of x. Now become y is equal to u raised to power n. Its derivative is n u n minus 1. Then we put these values in chain rule and we get the answer. If we have a reciprocal 1 over g of x, we can write it as g of x raised to power minus 1, then apply formula on it, n minus 1, minus 1, minus 1, minus 1, and then derivative of base. Now here we have a function y is equal to x cube plus 1 raised to power 9, and its base is x cube plus 1. So two functions, we have u is equal to x cube plus 1 and y is equal to u raised to power 9, because we let the base is equal to u. Now we derive both of these equations. In first equation we have u is equal to x cube plus 1, so we differentiate with respect to x. It becomes du by dx 3x square. Derivative of x cube is 3x square n minus 1, and derivative of y is equal to u raised to power n d by du. We differentiate it by with respect to u, 9 u raised to power 8. On both these we apply power rule. Now using the formula chain rule, we put these values in dy by dx is equal to dy by du dot du by dx, and here we put these values. Now in this question we have base is equal to a minus x over a plus x. Now y becomes u raised to power 1 by 2, and first we differentiate dy by du. It becomes 1 over 2 u 1 over 2 minus 1. In this question we let base is equal to u, and then y becomes u raised to power 1 by 2. We apply here formula power rule n minus 1, and then we differentiate u a minus x over a plus x with respect to x. Here we apply quotient rule. Derivative of a is 0 and derivative of x is 1, and then simplify, and then we both these values put in this chain rule, dy by du and du by dx. Now here we have y, same like question in 2.3, question number 14. We first rationalize these values, and then we let the numerator is equal to f of x and denominator is equal to g of x, and then we differentiate both these equations. F of x is equal to x, which derivative is 1, and g dash of x, derivative of a is 0, and derivative of square root term is 1 over 2, 1 over 2 minus 1, then derivative of base. We put these values in quotient rule. Here we put these values in quotient rule. Now we simplify these values. On numerator we take LCM, and we write LCM in denominator, and then simplify these values. Now here we have y is equal to 1 plus 2 square root x whole cube dot x 3 by 2. We let u is equal to 1 plus 2 square root x raised to power 1 by 2, the base of cube. Now y become u raised to power 3. Derivative of y is 3u square, and derivative of u is, we apply product rule, a dot b. Derivative of 1 is 0, derivative of 2 square root x is 1 over 2, 1 over 2 minus 1, and then a remains same, and derivative of b, in b we have x raised to power 1 by 2, and its derivative is 1 over 2 x 1 over 2 minus 1. Here we apply product rule. Now we put these values in chain rule. Now in this question we have n is a negative integer, and find its derivative. N is equal to minus m. We can write is 1 over ax plus b raised to power m. Now we let the base is equal to u, and derivative of it is n mu m minus 1. We apply here Quotient Rule, N over D. Y is equal to x raised to power n is equal to p over q, fraction value. Now we apply here qth power of both sides, so it becomes y raised to power q, x raised to power p. Differentiate of both sides. Yp derivatives yq derivatives qyq minus 1, and then derivative of base dy by dx, and x raised to power p derivative pxp minus 1. We multiply both sides by y, and on right hand side we put the value of y, and we divide pyq to the right hand side and put the values and simplify and get the same answer as power rule nx n minus 1. Now derivative of inverse function. Dy by dx also can be written as 1 over dx over dy. Now derivative of parametric equations. Here we have x is equal to 80 square and y is equal to 280. We differentiate both equation, differentiate with respect to t. Derivative of 80 square, because variable is t, 2t, and derivative of 280, derivative of t is 1, it becomes 2a. Now we put these values in chain rule. When we differentiate both equations with the same variable, then the chain rule is like this. We divide these values, and then in previous case we differentiated both equations with different variables, so we multiply these values. But here we have same variable, so we divide these values. Because here we differentiate both equations with respect to t, so we in chain rule divide these values. We can also differentiate by eliminating t from y. We put value of t and put in x, so it becomes y square is equal to 4ax, and then differentiate y square derivative is 2y and its power is 2 minus 1 1, and then derivative, always when you differentiate y, its derivative is dy by dx, and derivative of y raised to power n is ny n minus 1, and then derivative of base. Derivative of 4ax is 4a. Again we have the same answer. These are the two methods to find the derivative of parametric equations. First is to differentiate both equations with the same variable, and then apply chain rule, and in second we eliminate the variable t and then differentiate. Now again we have two equations, x is equal to 1 minus t square and y is equal to 3t square minus 2t cube. We differentiate both these equations with respect to t. Derivative of y is derivative of x is with respect to t, derivative of 1 is 0, t square is 2t, and derivative of y is we apply 3t square power rule. It becomes 6t1 because the power multiply with the base, and derivative of 2t cube is become 6t square. Then we apply the chain rule in division form. In this question we have both parametric equations but in fraction form. In both cases we apply chain or quotient rule. In first question we have 1 minus t square or 1 plus t square. Now I hope you learn these formulas are derivative of numerator into denominator minus numerator derivative of denominator divided by the denominator square, and you know derivative of constant 1 is 0, derivative of t square is equal to 2t because a derivative of x square is 2x. Now here variable is t, so it becomes 2t, and in last bracket again derivative of 1 is 0, derivative of t square is 2t. We multiply these values and the answer is here. Now we differentiate the second equation, 2t over 1 plus t square. Again we apply the quotient rule. Derivative of 2t is 2, derivative of 1 plus t square is 0 plus 2t. Then we apply chain rule, we divide these values. Now differentiate of implicit relations. Sometimes the function relation is not explicit, expressed in the form of y f of x, but an equation involving x and y is given. To find dy by dx from such an equation, we differentiate each term of the equation and use the chain rule where it required. The process of finding dy by dx in this way is called implicit differentiation. We explain the implicit differentiate in the following examples. We here have implicit equation because y and x on the same side. We differentiate with respect to x. Derivative of x square is 2x, derivative of y square is 2y, and then we write dy by dx. Derivative of 4 is 0, so dy by dx is equal to minus x over y. Now from equation we have value of y is 4 minus x square. We put this value in the dy by dx, so this is the answer. Now here we have y square plus x square minus 4x is equal to 5. Derivative of y square is 2y dy by dx. Remember this point, always when you differentiate y we write dy by dx. If we have simple y, it's derivative dy by dx. If it's power, then it becomes power minus 1, and then we write dy by dx. Derivative of x square is 2x, derivative of 4x is 4 because derivative of x is 1, and from here we find the value of dy by dx. And this is the other way to solve this question, but the first one is easy. So in this question we have y square, its derivative 2y by dx. Now in the second term we have x or y in product form. Here we apply product rule. Product rule is derivative of a, b is same plus a, and derivative of b. Here is x, derivative of x is 1, y is same, plus x is same, and derivative of y is dy by dx. And next term is x square, its derivative is 2x, derivative of 4 is 0, and from here we find the value of dy by dx. Now again we have implicit quotient y cube. Now its derivative is 3y square dy by dx, and derivative of 2x y square, second term, 2 is constant, and we apply on x y square product rule. Derivative of x is 1, y square is same, plus x is same, derivative of y square. Again we have product form x square dot y, derivative of x square is 2x, y is same, plus x square, derivative of y is dy by dx, and derivative of 3x is 3 because derivative of x is 1. Now derivative of y square is 2y dy by dx. Now we arrange these equation, we remain there with the values dy by dx in left hand side and move other values to the right hand side, and here we find the value of dy by dx. Now here we have two functions, x square plus 1 over x square with respect to x minus 1 over x. We name these equations, one is y and other is x. Now we differentiate y with respect to x. Derivative of x square is 2x, and derivative of 1 over x square, first we write it as x raised to power minus 2, then we take its derivative. X raised to power minus 2, its derivative is minus 2x minus 2 minus 1. Minus 2 minus 1 become minus 3, so we can write minus 2 1 over x cube. Then we simplify these equations, and derivative of u x minus 1 over x, derivative of x is 1, and derivative of 1 over x, first we write it as x raised to power minus 1, minus 1 x minus 1 minus 1, and it becomes minus 2, and then we apply chain rule. Okay student, try to solve these examples. If you have any problem, then underline and send it to me. Jazakallah.